Okay, this is Connor and Zoe's 2013 AP Stats free response, question number 4. The question is, the Behavioral Risk Factor Surveillance System is an ongoing health survey system that tracks health conditions and risk behaviors in the U.S. In one of their studies, a random sample of 8,866 adults answered the question, do you consume 5 or more servings of fruits and vegetables per day? The data are summarized by response and by age group in the frequency table below. See graph.
There's the data.
There's data. You can see it right
Yep,
there.
right there. Okay.
So here's the question. Do the data provide convincing statistical evidence that there is an association between age group and whether or not a person consumes 5 or more servings of fruits and vegetables per day for adults in the United States?
Okay, so first, what we gotta do is get our hypotheses. So, first, null hypothesis is that there is no association between age group and whether or not one eats 5 or more servings of fruit per day for the population of American adults. That makes our alternative that there is an association, and that is going to be at the significance level of 0.05. And there we have that. And what we're going to be doing is a chi-squared test for association. And that's good enough. Okay. You should write chi-squared test for association. That'd be chill. Okay. So while Connor's writing that, we're going to move over to our conditions. And our first condition is that expected counts are more than 5. So the official way, here we go, there's our chi-squared test. All right, so the official way to do expected counts is your row total times your column total divided by your grand total. But we'd have to do that for all 6 cells. So we're going to do this the fast and easy way, which is with the calculator. So Connor, let us do some calculator magic.
So we're going to go second matrix, go over to edit, and we're going to enter the data that is provided to us on the original graph.
In matrix 1.
In matrix A.
So
and from there,
there's our data right there.
From there we will go stat, over to test, up to chi-squared test.
Looks like an x squared. And then you're going to see in observed, it's going to do matrix A, which is where you put stuff. And then your expected counts, it's going to create them and send them to matrix B. So then you go to
So
calculate.
we're going to go ahead and calculate that.
There you go. And there are your data that we're going to use later. But for now, we're going to stick to our conditions. And
so we're going to go look at matrix B, which will now have our expected counts.
Sweet. Okay, so Connor's going to write up our expected counts in our nice expected counts table.
Oh, that's a horrible too.
That's good enough too.
It's horrible.
No, it's chill. All right. So, and you guys will see momentarily that all of these counts are well above 5. So this condition is a go. So while Connor is doing that, we're going to go through our next conditions. The next one is randomness. And if we go back to the question, we can see that it says right here, a random sample of these adults. So we know right there that randomness is a go. And see there we got our expected counts, they're all good. So randomness, check, it's given. Given, awesome. So next, we have independence. And the way we're checking for that is whether our sample was less than 1/10 of the population. So it was given that our sample was 8,866 of all U.S. adults. And there are millions of U.S. adults, so we're pretty much guaranteed that it's no problem. There you have it. There's more than that many U.S. adults. All right, so the last thing we have is disjoint, which means that each outcome can only fall in one category. Like you can't be 18 and also 36. And you can't eat 5 servings or not eat 5 servings. There's just no way that that works. So, there you have it. Our conditions are a go. All check. So, now we're going to go to our work. Here is the formula, so you can see, for a chi-squared test. That is on your formula sheet, if you use formula sheet, or you can just remember it. It's pretty simple. and now we're going to go back to do our chi-squared test. If you guys remember how we did that last time, go to stat test, go to the thing that looks like an x squared, and as long as you got your matrix, you're good to go. So there are our values. Connor's going to write those up, and I'll tell you guys how we got 2 degrees of freedom if you don't have a calculator. The way it works with degrees of freedom is you got your table, right? And you take, not counting your totals, you take the number of categories this direction and the number of categories this direction, subtract 1 from each, and then multiply them together. So basically we got yes and no, that's 2. Subtract 1, it's 1. We got 3 going in this direction, 3 age groups. Subtract 1, you got 2. 1 times 2 is 2. That's how we got our degrees of freedom. All right, so here we got our chi-squared value, but more importantly, we have our p-value. And that is going to help us make our conclusion. That's really important. So now, moving on to our conclusion. Connor, you want to read this one?
So because our p-value is 0.0112, which is obviously less than 0.05, which is our alpha, there is statistically significant evidence at the 5% level that there is an association between age group and whether one eats more than 5 servings of fruits and vegetables a day for U.S. adults. Therefore, we reject the null hypothesis that there is no association.
So there we go. We have our conclusion. Based on this data, there is most likely an association. We could have made a type 1 error if in fact there is not an association, but we're pretty sure based on that p-value that, that this test is good to go. So there was our 2013 AP free response answer to question number 4. This has been Zoe and Connor. Connor, say bye.
Bye.
Bye.